Hi everyone. Welcome to
Hello,
the
hello.
DataHub Town Hall
Mhm.
for July. Very great to see so many of you. I'm Melissa. I'll be kicking us off today, and we have a really good lineup that I'm very excited about. Um, so as always, please drop questions in the chat or the Slack as we go, and we'll get to them in the during the town hall or also in the end. So let's jump in. First, I would like to give some community updates on the next slide. Um, We had a podcast recording by Srupan Shirshanka with Grace. So it's live on LinkedIn, YouTube, and a bunch of other channels now. We'll drop the link in the chat. It's worth a listen if you want to hear where Srupan Shirshanka's heads are at on data, where data and AI is heading. They also talked about anecdotally a lot of their founding stories and how we came about in the company for the past 5 years. So it was a very interesting talk for a lot of us. The other big one I would like to highlight that's ongoing is the Asian Hackathon. We reached over 1,300 in registrants right now. There has been a ton of momentum, and there are 18 days left get your submissions in. So if you haven't signed up yet, please head to datahub.devpose.com and I'll drop both links in the chat after I hop off. And to give you a sense of what you can actually build, actually put together a demo that walks through uh, it end to end. And definitely check it out if you're on the fence about it. It makes the whole thing click and so much easier. If you still want to get your submissions in before the deadline. Um, and then the next reminder I want to give is on our big event in November, which I know is like still far down the road, but um, this is like at the core, right? The Context Summit is really about connecting with peers who are solving the same real world data context challenges that you, as you are, and walking through with very proven approaches for scaling governance, lineage, and context management with DataHub. So we are very excited to have a strong line of speakers who are practitioners tackling these problems at scale. And they're here at the Context Summit in November to share what they're actually working on. So if you're just getting started running DataHub across a huge organization, or you're already deploying but want to get better at it, this is the conference for you. And I'm sure there's something for you during context. So very excited to see you here, and please save your seat before our big event this year. With that, I'll hand it off to Lakshay to go through the rest of the presentation.
Awesome. Thanks, Elisa. One quick thing before we dive in. If you are not already in our Slack, come join us. It's where all the good stuff happens. And the town hall is being recorded, and recording will be shared in the town hall channel on Slack. Uh, awesome. Now, before we get our speakers, a quick sneak peek at something team has been building upon. So we are making up the like business metrics first class citizens in DataHub, governed with owners and lineage, one certified definition ready for your AI agents to use. So here is a quick look to it.
Introducing the DataHub Metrics Catalog. Your metrics are now first-class entities in DataHub, grouped into semantic models, each with its own owners, lineage, and governance. This is the semantic layer itself, comprising datasets, metrics, relationships, and dimensions. Drill into any metric for its certified SQL definition. A metric can carry AI context, so ask DataHub or the DataHub MCP server answers from the definition. Available in DataHub Cloud 2.1 and coming soon to open source.
All right. Thanks, Lakshay, for playing that video. I had a lot of fun creating it and picking the right music that fit the the kind of music I was listening to at the time. But more excited to actually share that we're finally making metrics a first-class citizen. I know we've had a lot of feedback from the community about how business glossary is great, but you'd really like to have metrics as a separate entity type and with all of the work that's going on with the Open Semantic Interchange OSI standard, we thought it was a good time to build out first-class support for that in DataHub. cloud. And good news is this is part of this current release that's going out with DataHub Cloud 2.1, but we'll also be releasing that to open source shortly after. So we want to give this feature to the community as well. And the idea is you should be able to interoperate your entire warehouse stack and your metrics layer with DataHub seamlessly. So I'm excited for this. And we have a few other similar registries being baked, and looking forward to sharing more in the next town hall. With that, handing it back to Lakshay for the rest of the program.
Thank you, Shirshanka. Great to have you on. Okay, here's what we have got lined up for today. First, we have Ronald from Miro on enhancing text-to-SQL accuracy with DataHub. Then we will have Maksym from Just a Takeaway on running DataHub self-hosted at scale. This is must watch if you're looking to scale up your DataHub to millions of entities. And then a community spotlight. We will have a chat with one of our longtime DataHub champion, and then we will close with a Q&A. So keep those questions coming in the chat, or there is a Q&A tab. You can use that as well. So our first story is from Miro. If you have ever pointed an agent at your warehouse and forced it confidently give you the wrong answer, this one is for you. Ronald, stage is all yours.
Hello all. Then let's start with this presentation. I'm Ronald Angel, lead product manager at Miro. Miro is a collaboration tool online where you can connect all your AI tools. And I will talk today about how we increase the accuracy of natural language to SQL from less than 40% to more than 90 using metadata signals within DataHub. So let me share the screen and I will present it. So first, what is the problem? It was already introduced. I think we all have had this problem. We point LLMs to the warehouse. It works magically for some questions. Actually, some people were happy, but then it starts getting the wrong table, the wrong answer for even things that are very simple within the organization, like give me the active users, right? Then people start just quietly leaving the tool and then they get frustration. We actually tested this within Miro using our evals bank. We got less than 40% of accuracy on this. Something important to take into account here is that we have within Snowflake, dbt, and Locker more than 20K datasets. So the landscape of our problem is huge, and that's why the LLMs, mainly connecting cloud to our warehouse Snowflake, was getting the wrong answer. Then we found that this is something I think you all have found, is that analytics accuracy is not a code generation problem. Actually, LLMs, they are good already at writing SQL. The problem is about context and routing. You give them enough business context and you give them what is the table they should use, they can write the SQL properly. Then how we measure what I have just told is we created 900 eval questions. Those were created manually by data experts within Miro across several business domains like finance, marketing, product, so on and so forth. Those run daily. Mainly, we are updating them on each model update, so on and so forth. And also, we run the evals on what people are asking live within Cloud, Cursor, so on and so forth. An example of this is what you can see here. So the question is, for example, what percentage of our premium accounts have two-factor authentication enabled? This is hard in this case. Then we tell here what are the expected entities. There are several, that's why it's hard. Also, some patterns that we are expecting within the columns. In this case, is the status. It shouldn't be only active, but several, and should use a very specific column within the data set. Also, you can see here gold SQL and the reference SQL, also alternative SQL. And finally, we also test the final result type. It must be scalar, a value within a range, so on and so forth. So based on this 900 evals and using a cloud connected to a Snowflake was where we got less than 40% of accuracy. But then we started working on this. So how to improve this? We took this from less than 40%, as I said, to 90% in 4 different movements. The first one is, let's connect this to the metadata layer. We use DataHub. The second is a framework for metadata signals. I will explain later. And finally, what we call the semantic layer and good metadata documentation. I will go one by one. First step. Of course, we were connecting, and this is simple, the cloud to Snowflake directly. In Snowflake, you don't have metadata. Technical people would have the DBT repo open, but business people don't. Then they didn't have any metadata layer. We have everything centralized in DataHub. Our first step is let's put DataHub in the middle, basically the NCP, and in there we will expose descriptions, tags, glossaries, columns, so on and so forth. And then in this case, the agent will finally understand the models. These are all the tools that we were using, mainly before Snowflake. We were using DataHub for search, for lineage, and also to understand the schema. And with this, we increased that accuracy from 40% to 65%. Better, as you can see, but still low, right? So SQL was fluent, better understanding, but still wrong table in more than 30% of the cases, which is quite high. So what was the next step? This is something to take into account as well. Basically, the search method within DataHub works for a single entity. There is already a draft SQL method there that helps on this, but we had to split the question, the natural language question, into facts and dimensions and make several search in parallel to make it work. In that case, we split the question, the natural language questions, and then we call DataHub for each of the concepts and dimensions there in order to get the final SQL. Then, after the search, the default we have in DataHub is that we rank based on usage only. And this wasn't working very well for us because it didn't have any context. So we started creating a framework for metadata signals, and we were boosting the final candidates and sort them to get what was closer to the actual answer we wanted to give. What was this? Basically is creating a boost on every semantic anchor or semantic signal that we could see. The first one is we have a semantic layer, so the most important data products within the organization are already within a data product and are exposed through an output port that is a semantic view. So whenever we found a semantic view, we were marking this. Whenever the model was already owned by a trusted analytics team with stored analytics queries, we were also marking this based on the priority, based on the schema, and also based on the quality of the documentation the models had. The 5 gaps we found on the 5 signals are this. The first one is the schema ranking, right? When we started analyzing why some evals were failing, one of the most common ones was, okay, this is getting the information from the raw table. The raw table is not ready. So we can have a schema ranking, marking those closer to the data products and the semantic views higher. That's the first one. Also, something that is simple for us is that most of the metrics are already connected to Locker, so those with the lineage to Locker also had a higher level in terms of the ranking. Another problem we saw there is it was in some cases being routed to tables that were stale or unmaintained. And this was a very simple quality usage gate. So only return models with more than 5 people using this and with good quality. And finally, what I already explained, try to decompose the question to find what is a fact and a dimension, and in that case, joining both of them. With this, we took the accuracy already from 65% to 85, as you can see here. Now better, but could be even higher. What was the last mile for us? So now we can find the main entities, we can rank them based on metadata signals. It's giving us a better answer, but then what is failing? We went to the evals again, and then we found that in several cases, it was more about the quality of the metadata. So for example, some models were not well documented, right? So we went to the most important ones, we made data products and we documented them properly, meaning grain at valid ranges in this case. Another example, there were some columns that were deprecated. The eval said, don't use this column because this should be deprecated, but the column was already there, DBT and Snowflake. The agent doesn't understand it, so the fix, very simple, just mark that as deprecated in the metadata. Another that is better and very important is try to document all the concepts within your organization properly. You have now the metrics layer that I just explained a few minutes ago, but also you can use business glossary, terms, and tags to mark the most important data products and models you have in DataHub. And finally, try to expose everything, if possible, through a semantic view, through a data product, or a model you can mark as higher in terms of metadata signals. With this, fixing the most important models and data products, we went now to higher than 90% in this case. Then finally, we also discovered that there were two modes. Some people want to explore data broadly, and in that case, they can just search. But some people, they actually want a higher level of determinism. So the first step in our skill is we ask people about what they want. Some people can go broadly, and in that case, they can get from 85 to 90%. Some people can say, I want only data products or semantic views, well documented. And this gives us a higher than 90% level of accuracy. As you can see here, this is an example. We are saying how many active users do we have. Then I want to search only on data products. We have a data product called product engagement and a semantic view called SV product engagement. Everything will be routed here, and we will have, with a higher level of possibility, a good answer from that natural language question to SQL. And with this, I finish. This is basically the process we follow to take a wrong answer with metadata signals and with a semantic layer in the end to good SQL, to a good SQL and a good answer for business people. Thank you very much, and that's all.
Thanks, Ronald. That was fantastic. Next up, we are staying in production, but shifting gears. So from getting an agent accurate to running data at serious scale, Maksym from just e-takeaway is going to take us behind the scenes. Maksym, over to you.
Hello, can you hear me and see me?
Yeah, we can see you.
Yeah, that's perfect. Then let me share the presentation. Yep. Can you see the presentation?
Yes. Yeah, we can see it.
Perfect. So hello, I'm Maksym, but you can call me Max. I'm a data engineer at data platform governance team at Just Eat Takeaway, but I'm located at Canada. So I'm basically under the SKIP, which is one of the representatives of Just Eat Takeaway in Canadian market. And I have been with the Jet for almost a year already. So we are building a governance-first data platform where discoverability, ownership, quality, and accountability are foundations of the platform rather than controls that are added after when the data was basically created or transformed. And the Data Hub is a key capability within that wider platform. It is our metadata, discovery, and governance capabilities. DataHub helps us to reduce the information silos, bring everything together, technical and business metadata, context, ownership, quality, and lineage, basically. Our role is to operate the capability reliably, enable glossary, domain ownerships, and data product management. Since we're viewing a data at the first-class citizen, so we're calling it data product. And also automate metadata from contracts and the pipelines that we have. But the business and data owners remain accountable for their content and decisions that they're making. And we, as a data platform governance team, just providing the capabilities that are they requesting. So today we will have let's call it 4 sections. I will start with DataHub within our wider governance first data platform. Then I will explain how we manage governance as a code. From that, we will move to the operational side, the ingestions, the architecture, the observability needed to keep the technical metadata current and proper. And also we will discuss some gotchas that we encountered while developing DataHub in our platform. And finally, I decided to add also a future perspective. What are we currently developing and making a data product marketplace and using a data hub for that, where we declare the contracts, pipeline context, create already connected lineage in the data product, and ultimately also enabling clear AI discovery. So this is our data hub homepage. It's how it currently looks like. We currently catalog more than 400,000 data set, including dashboards, charts, pipelines, glossary terms, and we currently have 145 data products. That metadata is coming from BigQuery, Tableau, Airflow, DBT, mostly. And the integration with the data hub pattern depends on the source. I will discuss that later on how we ingest different data. The key point there is that the data hub is not the data platform itself. It does not hold the business data. It's a core capability within the platform that brings distributed technical metadata together with the context needed to use data responsibly inside the Jet. So basically, DataHub solves the big problem for us. That shared context helps people move from I found the table to understand what this data actually represents, who is accountable for it, how it is produced, how it is transformed, and whether it is relevant for their use case. At this scale, DataHub is no longer for us, it's just a catalog. It's a production metadata capability, and basically it needs to be operated accordingly. We see DataHub, it brings us 2 kinds of metadata. The technical metadata, such as datasets, schemas, pipelines, lineage, the usage, and is continuously discarded from the platform. But the business context that comes that makes those assets useful and understandable, such as glossary definitions, domains, ownership, tags, and data products, needs a control and reviewable way to change it. So on the next slide, I will just we will discuss what's the governance as a code. So this is like the typical flow of how the user can provide a business metadata to the data hub. So yes, so I mentioned, this is like different from the technical metadata that we continuously discover from the BigQuery, Airflow, dbt, Tableau. This technical metadata mostly explains us what exists rather than what it actually means. And the governance metadata provides the business meaning for that accountability and context that makes it trustworthy and reusable. So the journey starts with a version YAML definition and GitHub. A contributor can define or update a glossary term, assign an owner, create a domain, or create or update the subdomain, add tags, and describe the data product. And then it gets as a pull request. Basically, for the platform governance team and for the governance team, this creates a clear audit trail. We can see what changed, why changed, and who approved that change. And then we also have automated checks that validate the structure before it's actually being merged, so that it follows the standards, JET standards. Yes, up to that, it also helps us to introduce new standardizations for the governance inside of a JET. And also, I will also discuss it on how we run the DataHub. We have the GitHub repo that is basically divided between two DataHubs instances. We have one is running for the development and one for the production. To the next slide. So yeah, now we will be moving to the most important part, is how we are running the DataHub at scale inside of a JET. So basically, data sets and all of the information that we're pulling into the DataHub has the entities, basically the metadata information. And this slide shows the operational workload required to keep the technical metadata current. And as you can see, since mid of 2024, metadata ingestion in the JET has grown steadily, and we peaked processing 1 million metadata entities in a month, reaching around 12 million cumulative entities by November 2025. It's important to note that it's ingestion volume, not the current count of the catalog assets. It reflects the continuous change generated as the data platform and pipelines and data products evolve. At this scale, as I already mentioned, the DataHub is not just a catalog UI. It must be operated as a production metadata service. And because of this significant volume of metadata entities ingestion, we experienced 2 GMS memory incidents that we detected through monitoring and our users of a DataHub, which prompted us and me and our team to review the capacity and scaling resilience. Here is the most interesting. It's how we actually manage the DataHub inside of a JET. So we can basically move it into 3 parts. We have a sources, then we have the self-hosted part, and then we have also managed resources in that. So on the left, that's the metadata ecosystem. So today, a JET DataHub collects technical metadata from platforms such as BigQuery, Tableau, Airflow, and dbt. It makes context available to data consumers, which are like business, analytics, and governance team, as well as AI assistants that are sitting in a Slack, so basically like virtual colleagues. For the sources such as BigQuery and Tableau, we do have running ingestion receipts inside of a DataHub UI that pulls the technical metadata into the catalog. And similarly for the Tableau, so BigQuery and Tableau is basically working on a pool-based where we use the DataHub UI and its ingestion receipts. But for the transformation layer, which is Airflow and dbt, for the Airflow, we are using the DataHub Airflow plugin, which basically emits the context directly. A DAC is represented as a data flow and a task as a data jobs, where task inputs and outputs can be identified basically. it can also build a table level lineage through the orchestration layer. This gives users not only the data sets itself and how the data sets are connected between each other, but also what actually happened to between that like input table, then the transformation and then output table. And for the DBT, it works a little bit different. It's also a push based, so it pushes to DataHub, but sorry. So basically, DBT builds the artifacts and test results that are being pushed to the Google Cloud Storage, and then by another Airflow DAG, it takes that information and pushes it into the DataHub. And then, yeah, it pushes the model and the data quality context into the DataHub. And in what's in development currently is a data product operator. It's mentioned as in development. It's a part of our new platform we are building and is intended to emit the input contract, the implementation, the pipeline itself, and the output contract, what is being produced by the pipeline directly into the DataHub, helping marketplace metadata stay aligned with the data products and the pipelines that produces it. So it includes the information gathered from the BigQuery, AWS, Athena, and so on and so forth. In the middle, we have a Google Kubernetes engine that manages the internal parts of the DataHub, let's call it this way. It also the front end and GMS, which is the metadata service provide, and it basically provides the experience for the user interface experience and the metadata API. Then we have a DataHub Actions, which executes ingestion workloads, while Kafka Schema Registry and the MCE process metadata changes asynchronously. And on the right, we have managed dependencies such as PostgreSQL, which is highly available system of records for persistent metadata, and Elastic Cloud, which provides search and discoverability. So the DataHub is self-operated, but intentionally hybrid. We operate the application and metadata processing paths while relying on the managed services for durable storage and search. While developing a DataHub inside of our platform, we got several issues, but yeah, I picked it up probably the most interesting and most reliable for the people who actually will self-host the DataHub. The first one, we had an issue with DataHub Action Spot. So the DataHub Actions is the execution play for managed UI ingestions. It runs the ingestions received that scan BigQuery, Tableau, so on and so forth. And we observed the failure while being in development. Google Kubernetes engine basically evicted an action spot during an active ingestion. So basically, the DataHub UI remained available and continued to show the run that the ingestion is running, but while execution activities actually stopped. I will show the sequence for better understanding on the next slide. And today, basically, to catch all of those issues, there are two potential solutions for this. Okay, one solution that can help a lot to reduce this issue. We currently have the Google Cloud Monitoring that gives us important service health signals like action CPU and memory utilization, uptime, pod restarts, and replica mismatch. This controls tells us whether the executor is available and under pressure, but they do not prove that the individual ingestion is still progressing or that its metadata is current in a DataHub. So the first improvement is to automate the signals. So something like a run activity alert. If the run is still shown as an active, but there is no execution logs in the process, then we can be alerted. But the second improvement that we have found out that can reduce the likelihood executor distribution is just to make the DataHub Actions post to be on a dedicated Tainet node. And after measuring the actual demand, we right-size the CPU and memory requests. And that meaning that the resources from that pod won't be taken off, and at some point the pod will not be actually evicted. So basically this is how it looked like. So the ingestion began normally, actions was producing logs and metadata, but at some point Google Kubernetes engine then evicted the actions pod while the run was actually active. The UI still showed the ingestion is running, but the execution activity became silent. No new execution logs appeared, and no further metadata actually being followed. So that's why the health pod isn't sufficient itself. A replacement pod or available UI does not prove that the particular ingestion is still making progress. The next one gotcha that we got, it was discovered 6 months ago. GMS, we had an issue with the GMS, and GMS is serving paths behind the DataHub UI and API interaction. It processes catalog reads and writes. So when, reads and writes. But at some point, the users were coming, and we also saw that the UI is flickering, and sometimes the API requests that they're making to the DataHub, they were failing. And then we start looking at the GMS, what is actually happening. What we found out is that during the incident, maximum memory utilization repeatedly reached like 83% of what was actually provided to the GMS pod. At that level, the the Java virtual machine had too little free memory headroom to work efficiently. The result was frequent blocking garbage collections, which caused JVM to start garbage collection to reclaim the memory, which causes the direct pauses to the UI and the API interactions. We treated at that time as a capacity and resilience issue rather than waiting for the out of memory failure. And we were able to increase the limit from 10 gigabytes to 12 gigabytes and adjusted the container a very Java virtual machine setting. So it used instead of 75%, 85%. And as a result, we saw that the GVM collection time reduced from 11 minutes to 27 seconds. We also included that we have 2 GVM replicas that are running on a different separated nodes, and also added a very important pound monitoring alert that if the memory utilization is sitting above the 75% more than 15 minutes, it gives us alert that something is happening with the Java virtual machine on that side. As a result, great UI stability and much lower memory baseline. And the third one gotcha that we have is the lineage completeness. Lineage is the fundamental for impact analysis and for building trustworthy data products. People use it to understand where the data came from and why be infected by this change, and how a product is connected to the rest of the platform. In this case, DataHub lineage graph was visible, but it was incomplete. Due to the nature of our data platform, when the DBT models are running, they create temporary projects and tables inside of the BigQuery. It's a feature of our platform. And when the BigQuery flow passed through these temporary tables, DataHub could not infer that full pass. That meant some upstream and downstream dependencies were missing. This is important because a partial lineage graph can create a false confidence in whether it's trustworthy and correct. It looks though we have traceability, but teams and tools relying on that graph cannot see the actual end-to-end data flow. So the resolution that we had is a BigQuery audit log ingestion that runs weekly and reads a rolling 7-day window of BigQuery logs. Why audit logs? Because they preserve the executed query history, which gives the DataHub the evidence it needs to infer the lineage through those temporary tables transformations. even though the table, intermediate table, is not available as a persistent catalog entity. The result is that the missing upstream and downstream lineage can be recovered and made visible in DataHub. And the lesson here is that the lineage needs validation against the source platform sometimes, especially for the complex transformation. And the visible graph is valuable only when it represents the actual flow. So I have covered the operational foundation, the gotchas that we encountered, the most important one. And now I want to shift the direction a little bit in a different way on basically in what we are building currently at the new data platform that we have. So this slide shows the direction of our platform for the automated data product marketplace. The key shift is that data product is not simply a page that someone fills later in the catalog when the data is already sitting in there. The data product becomes a the data platform is becoming the declarative platform resource where everything is defined through the YAML. The definition starts with the product itself, its name, domain, subdomain, owners, and governance policies. Kubernetes operator is validating the data product standard, make sure that the lifecycle changes are valid, and apply the required approval gates. The most important part is here is a contract interface. Each data product required to have an input and output ports, where in input and output ports you are defining the contract. And the contract is the agreement between a producer and a consumer that the producer provides this schema with this quality rules and with this SLAs. And then the streaming or batch implementation connects those declares inputs to declared outputs. And that's goes all under the data product, which then creates the connected dependency graph by design. The product states what it needs, the pipeline states how it transforms it, and the output contract states what it delivers, basically. And DataHub then becomes the marketplace projection of that resource. It can receive the data product, its contracts, its data sets, pipeline jobs, and the lineage that follows from the declared input output to output relationship. So yes, that's basically the direction that JET is going. We're building governance first data platform. That's it from my side. It took a little bit longer. I was expecting 15 minutes, but thank you everybody for listening to me.
Thanks, Max. That was on time. Cool. So I think a lot of you just saw your own war stories in that one. So as we move into our next segment, drop it in the chat if you have run into the similar things running data at scale. And if you have solved it in a different way, we would love to hear it how. Also, if you have any questions, this is the right time to ask. We will pick it in our pile. Uh, all right. For our last story, we are doing something little different. We have got someone who has been part of this community since the early days, our DataHub champion, and who has bossed this project to grow up till today. So, Tim, welcome.
Hey, can you hear me?
Yes, we can hear you.
Yeah,
Hi, Tim.
great. Hey.
How you have been? Could you tell us a bit about yourself?
Yeah, sure. Hey, yeah, my name is Tim. I'm working as a data architect for Cloudflight. I'm located in Innsbruck in Austria, which is one of the largest cities in Austria, but still a quite small city, placed middle in the mountains. I love being outside, so that's a great place to live. Yeah, I've been around with DataHub for quite some time, and I'm happy to share today something about what I've seen so far, how the community developed, how I got into the community, and how great it is to be part of the DataHub community.
Awesome. One thing, you are living at my dream place near the mountains. I always felt to move to those places. But yeah, now could you take us right back to the start? Like, how did you first ran into DataHub? What was your first thing that get you this tool?
Yeah. Yeah, I think it was around 4 years back. We were also just about building a data platform for a customer, a larger one, and had a problem that we had a lot of tables and data assets and data products, but they weren't really discoverable. So no one really has known about them, or how the data project itself looked like, and what the several attributes meant. And so we were looking for solutions. The solution we used, or the solution has been used back then as a, let's say, governance solution, was just Confluence pages where where the schema of the page tables was documented and some descriptions were added. And we said, yeah, that can't really be the best way to do it. And so we were looking for data catalog solutions, and DataHub was one of the solutions we found, and was back then the most promising one from our perspective. Also with its vibrant community. DataHub was very much very was not that mature compared to what is it is today. It was also more focused on the typical catalog features like discoverability, lineage, documentation, and all that kind of stuff. Um, yeah, and that was how we got into it. And we then tested it and got more and more in it, and really liked the capabilities of it, and then also introduced it as a production service, as Maksym just shared. And it was a great addition to the data platform capabilities back then. Yeah.
Yeah, love that, love that. I think most of the community folks get to into data hub into similar ways, and they must have the similar stories. So I also recall you went from using data hub to actually building on it and then helping others in the community back. So what pulled you into contributing? Any tips for the folks out there wondering if it's worth, and how has been open source paid off to you, and
Yeah.
even for your company, like when you implemented data hub and contribute back?
Yeah. Yeah. So we deliberately chose an open source tool back then because we wanted to be able to customize it to our wishes and our requests. So that was really a core asset of DataHub. Back then, we built a data platform on several AWS services, so based on Athena and EMR for processing. So it wasn't that typical data platform like using just Databricks or yeah, the classical open source stack. And so we had some stuff that wasn't working out of the box. Like for example, the Athena connector was already existing at DataHub, but didn't have all the capabilities we needed. And that was the first step where we really started in yeah, extending the existing connector. And what brought us then to contributing it back to the community was one. A community just lives when you also give back to the community, but also what was very important to us, having custom changes and kind of forking the project always creates some sort of depth, and you always need to stay up to the changes of the project and always need to take care that your fork is still compatible with it, and that is really can grow fastly out of your hands. So that was one of the main motivations also to bring the changes back so that they're part of the official Data Hub version, and the community can take care of it. And I think that was also what really paid off for the company in the end. Us having us spending less time on keeping our changes up to date with the official version of Data Hub, and yeah, also some kind of recognition, I'd say, right? So everyone can see that this team or this company has been working on DataHub and bringing things back to the community. So that's always great to see, I think.
Yeah, I completely agree with that. If like if you have found something that needs to be improved, or you want to add some feature, I think once you add it up, it gets evolved with the open source with the help of other community members. So it's worth it contributing back.
Yeah.
And one thing from our side, that Athena connector you worked on is still part of what people build on today. So thank you for that.
Yeah.
Yeah. And you have been a champion for a while now, right? So how's the vibe being a champion? Keep you like around this community all this time?
Yeah. I mean, the vibe as a champion is not a lot changes. I mean, it's nice to be part of that community and to engage with it. Um, One of the nice benefits as a champion is to be closer to the Data Hub team to get some insights in what's planned, what the product is going to develop, and also being able to give early feedback on features or product ideas. Um, that's really cool. And yeah, I generally just also like the Data Hub community, and that's why I keep engaging with it. It's cool to see so many knowledgeable and capable people out there helping each other, and that was also something that made it very easy for us to get into Data Hub back then, because every question you had, anyone could give you an answer in Slack and really helped you. Didn't necessarily need to be the Data Hub core team, just any random person from the Slack team. Also, a lot of these people then ended up as champions. But yeah, so it's just a great community. I think that's what makes being a champion special. Yeah.
Yeah, and that's exactly why we revived this champions program to recognize folks like you who show up in the community and not just at the back end code, but in the questions you answer and things you share. So, and honestly, for anyone watching who has been active in the community, this is a nudge for you. We are love to have you in the next champion cohort. So keep contributing, and we will reach out to you as well. Uh, Cool. Next thing, I know when you started with Data Hub, it was just a catalog, right? So you have been had a front row seat to Data Hub, going from catalog and looking into it as a now full context platform. I think last 2025 year was the evolution of the Data Hub. So also right now, also you just saw the Ronald from Miro, right? How Data Hub has a context layer changed the game for Miro's agent. So what does that shift look like from like where you are sitting right now?
Yeah, I think, I mean, saying it nowadays is just easy, but the change just feels natural, right? I think if you back then when we started with building up metadata in a good quality, you will benefit from that very much today, because that's just the foundation of your agentic or context layer then, which your agentic use cases will profit off very much. Um, yeah, so it kind of feels like the logical next evolutionary step, and yeah, it just feels like a round picture, I think.
Yeah, it's a good thing. I think this evolution to make it ready for the I think the main users in the coming era is the AI agents only, so they could get the same capabilities that a human had to view the data catalogs. Okay, last one for someone watching who is thinking about their very first open source contribution. What would you tell them?
I mean, basically, stop waiting until you feel ready for it or expert enough. Just go out there. I mean, the community is really nice. No one really blames you for not being perfect. And the community is just growing when people are sharing things and standing up. Um, Waiting until perfection is so perfection is never happening. So just go out and engage with the community. It also doesn't need to be a code contribution. Just raise the questions, answer to the one or other question in Slack. If you already beyond that, maybe come up with a blog post and share what you're doing, or be part of the town hall whatsoever. But just go out there and get in touch with the community.
Yeah, love that. Completely agree on that. The open source contributions go beyond just opening the PRs and fixing the codes. To
Exactly.
we'll
Yeah.
be helping with someone with the in the community, answering question, writing a blog, as you said, right? So I think yeah, this journey will continue as a champion, and it was great hearing from you, and thank you from the that your long view perspective that you shared. So. Now, let me check if there's some questions. Let's will wrap up this month's town hall. Cool. I don't see any questions, but if still someone has anything, community is always open. Just go and ask up, and speakers will be happy to answer there as well. So that's a wrap for our July town hall. And huge thank you to our speakers, Ronald, Maksym, and to Tim for sharing such honest, real stories today. And thank you all for showing up for the questions and for making this community what it is. So if today sparked something, take it to the Slack and ask questions there and chat with each other. Two quick reminders before you go. Our agent hackathon is still open. Submission closes August 10th. And we have grand prizes for the around $6,000 and $3,000 per category. And if you are interested, there is a agent hackathon channel as well in the Slack, so you can come and meet the fellow participants. So, and another thing is save the date for Context 2026. If you want to apply as a speaker, CFPs are still open. It's our virtual summit on November 4th. So yeah, keep contributing, keep sharing your learnings with each other, and we will see you next month. Take care, everyone. Bye.